So in this video, we can see the Project 5 UK Road Accident Time Series dataset. So the project is in detail explained about we need to get the predictions of the road accident in the UK between 2005 to 2014. So which is also include and also some limitations with corresponding to the potential causalities due to some road accident, and also most of the affected accident vary in the natures of the speed, and also the highway authorities may not be having the notches of the road accidents. So the safest way to conclude about this how much accidents we going to be get in the futures, and according to that we can also take some kind of the safety measurements and also safety conditions like causing those accident and road types, geographical regions well known for this accident. And along with, we will also take in the data set from the Kaggle. So I also provide the link here. If you just click on this link, you will able to see this Kaggle dataset link. Under this, you will able to go and download the data sets with corresponding to the UK road accident. So in this data set, we have different kind of the CSV file from particular date to particular year. So you can directly extract whichever the year you want and try to do some kind of the analysis. Then we will also go with the model building corresponding to the time series data set. So yeah, this UK government assumed has a traffic data from the 2016, and there are so many records of found with accident data sets 1.6 million. In this process, they are also going the compared traffic with the corresponding data sets and the huge picture of country undergoing this change. So yeah, basically we have from accident from 2012, 2014 and 2005, 2007 .csv files. So we can play around with this CSV file, whatever the information we had, then we can go ahead with the modeling part. So I'm using currently Kaggle. With regarding some of the plots may not be appearing, the Google Colab having some kind of the limitations to set up. So let's try with the Kaggle. How does the Kaggle dataset is going to be very helpful with corresponding to the EDA analysis. We can also play around with model building. So these are some of the questions we can also focus more on the EDA part so that we will get some idea and about the data analysis on this UK road accident, from which location to which location, and also from which period to which period, what exactly the trend and also the seasonality, since we are already working time series analysis data. So let's go with one by one questions so that we will able to understand what are the important perspective of these kind of the questions. Then we can focus more on the model building. So I'm importing some of the libraries which you all can see here. So these are some of the libraries which are going to be useful for plotting and also to do any kind of the 3D and also the 2D plot, the plotty and also the GeoPandas. And we will also go with the Matplotlib and Seaborn. And the Chart Studio also one of the plotty library which is going to be expressed in terms of much better way we can zoom in and zoom out. So I'm importing bunch of the CSV files as you can see here. These are some of the CSV files, and also we're going to be imported those CSV files with corresponding to each and every date. So by using these each and every date information, we're going to be combined or maybe going to be concatenated with these files so that we will get the entire data for the UK accidents. So I'm using the UK accidents to get the concatenated, and let's play around with the UK accidents data frame. So UK accident having, is there any kind of the missing values? We don't find that much of the missing values, but few of them having more than 10,000, also more than 1 lakh also. So let's see how does the data is looks like with corresponding to these kind of the features, and how does the correspond the features needs to be helpful in terms of the ED analysis or the model building. So whoever having the greater than 10,000 null values, I'm just going to be dropping those features so that it may not be make sense to understand instead of waiting for those imputation and also permutation purpose, we can directly dropping those columns. And along with, we use it to do something called as imputation with whoever having the null values less than of the 10,000 missing values. We need to be imputed with 0. So dropping the null values with corresponding to whatever the null values we had. and the shape is remaining is 30. So at the time we are going to be get as the shape is very high when compared to that. So 33, so three records going to be dropped with corresponding to that. So this is a data frame we are going to be play around with some of the EDA analysis. We can also do some kind of the cleaning and also the pre-processing in the future. Accident index and the location is thing OSSD and location northing and longitude, latitude, police force, accident severity, the number of the vehicles, number of the casualties, and the date. So different kind of the features we are going to be play around with the time series analysis. So let's go in with the time series analysis and try and importing some of the database we had lad.csv additional data sets. So yeah, these are some of the additional data sets we're going to be used. So by in this we are going to be having OSN code, highway authority, and subgroups. So in the network, some of the classification kind of the task we're going to be performed with corresponding to these additional data sets. So in this also subgroup and subgroup description and supergroup description along with the density range and also the rule range. So let's merge these kind of the data frames which we had for the lat3 and also the lat4 so that we will get the common value for the both data frame which is a subgroup. So I'm joining or merging with corresponding to these two data frames so that we will eventually get as a complete data frame. So we just drop those columns whoever having the 1 lakh records. So more than 1 lakh records, we needs to be somewhat tune or maybe somewhat append the data sets which are having the null values. So I'm just creating the for loop so that it will eventually add whoever having the 1 lakh record more than of the 1 lakh record of those null values. So we are going to be drop those null values in this case. So we had two observation or two different kind of the features which were going to be having the more than 1 lakh null values. So we are going to be drop this one. So this is the final data frame we are going to be get at the end and some renaming with corresponding to the domain knowledge as we know. So we can read some of the description about the road details and also the OSN to the lat code. So some local authority the highway and along with the OSN code is nothing but a lat code. The code is nothing but a lat code like that. So just rename those corresponding to the columns or maybe the future so that you will able to find those kind of the nomenclature and we can also use to for joining purpose for the other data frames. Join with corresponding to the LAD data sets along with the UK accident data set so that we will going to be get entire data sets whatever we required for merging all these things. So let's play around with corresponding to the additional data sets and also the UK accidents data sets with corresponding the different years. So what we are going to do, we are going to, since it is going to be very large kind of the data sets around the 1.5 million rows, it are going to be converted the accident data frame for the 2014 year to get the data frame of the geo data frame. So I'm going to be extracted by using that year 2014 only so that we will eventually use that and convert into different kind of the formats and also the plotting with different different plotting libraries. So convert that accident data frame so that we will eventually get 2014 records whoever having the geo information with corresponding to the geo data frame. So geo data frame having only three columns with corresponding to the 18,000 records. So let's go and visualize some of the road accidents based on the different categories like region wise or maybe the settlement areas or the road network groups. So let's plot around with corresponding to the data frame so that we will able to identify with able to see how many records are shown in the particular areas. So I'm just using some definition like plotting the plot, mapping with corresponding the plot so that we will eventually get how many road accident occurred based on the various features. So we will eventually give some colorness and also the figure size and line weight. So these are just a functionalities in corresponding to the plot library. So if you want, go and check out the plot documentations so that you will able to see all the information corresponding to this. So let's play around with UK 2014 data sets, accident data sets along with geometric shape and data frame and the region and also the country with corresponding to the future according to the regions we require. And let's see. So most of the plots or most of the area is occurred for the northwest England and also the Scotland. So in this population, and also you can see the southeast England also having more around those accidents when compared to the Wales and also when compared to the West Mills in England. So let's also see with the supergroup name and the settlement areas. The settlement areas having the huge impact. You can see the huge impact with corresponding to the countryside living along with town and country living, or maybe the urban and settlements. Some of the cases. So determines with respect to the group, super groups which correspond settlement areas. And let's also see the road networks. How does the road networks going to be in the UK based? So so most of them as separately networked or mixed network authorities, maybe some of the cases what we going to be see is so very sparsely network, or maybe you can say the rurality of authorities. So let's again go with few of the questions to analyze the data. What is the trend of the road accidents location in UK from 2005 to 2014? So by using this trend, what exactly the observations we are going to be drawn? So we're going to be get what exactly the trend is from this point to this point, along with the road accident in particular locations. So let's see how does that going to be arrived. So I'm just using the facet grid to draw this kind of the plot by using the year as a futures, and I'm also using as a hue for the region and country. With regarding, I'm using a data frame for the UK geometric data frame. So here was the trend corresponding 2005 2014 the road accident. So different kind of the plotting nature with corresponding to the latitude and also the longitude. So depending on the coloring, we are going to be see which country or which region it is. So the pink color shows as a London of the England, and the violet color shows as a northwest and also the England and northeast England. So like that, different color shows. You can also see the legend here, so that you will able to identify which color it is, which color it belongs to also. So the quickly observe the values from this above plots is the rate of the accidents. It's going to be geometrical distribution. So geographical distribution when corresponding as a pretty remind has a same location where the accident is going to be occurred in the past. So like to be same location where the accident will occur tomorrow or maybe the next, right? So which is also going to be some kind of the trending nature which may be occurred some of the cases, right? And also due to some high accident rates in the UK between 2005 to 2014, in this year accident trend will be visually better than the either and the line plots and also the bar plots. This can be done in this upcoming classes. So let's see how does that going to be happen. Convert all data frames into the date time format so that we will able to get to extract the date, month, and also week days and also the month days. So I'm just extracting the date information and also the year and the day, and along with the numerical type week in the month and the week in the month, so that we'll able to get the month wise also data. So let's also figure out the timestamp also converting into the time delta format so that we will eventually get these kind of the time formats. And along with the hours, so we're going to be extracted by using the time so that eventually we will get the hours also. So let's see how does that going to be helpful in terms of the other questions. The second question is what is the rate of the accidents, that means the number of the casualties in the UK between 2005 to 2014. What is the rate of a road accident based on the different UK regions, as it has been same in every region since 2005. So we need to figure out what exactly the rate of the road accident. So let's see the road rate of the road accident, the number of the casualty. We need to good group by some of the values so that we will going to be get corresponding to with number of the accidents. So I'm using UK data frame with corresponding the year we had, and let's extract those kind of the values corresponding to the 2005 to 2014. So I'm using the scatter plot to get to know about how many rate of accidents we have faced, and along with we're also providing the different colors to know about the year and also the number of the casualties. So let's check about these kind of the scatter plot so that we will able to understood about this number of the years of the number of casualties. You can see the line is practically decreasing at the point of 2010 and also the 2011, but some of cases 2012 is again increased when compared to whatever the value, the peak value, whatever the peak value information we had 2005. It may be slightly higher, slightly lower than that, but not touched in the peak value. But it has been happened in the 2012, and again slightly drastically, you can say again drastically change it into 2013, and again is slightly increasing nowadays. Maybe we can also see this pattern in the next future. So we can conclude that spike so that we will able to understood about why it's going to be happen with corresponding to the different kind of the reasons, maybe the region or number of the casualties, or maybe the different kind of the road types. So let's figure out what exactly the records for the different region. So I'm just extracting with corresponding the data frame what we had. Just go with the features for the region and country so that we will able to identify number of casualties along with counting for the sum for the group by. So different kind of the rates of the road accident in the UK. So you can see the London has having this hash symbol, and the red color is the northwest. So um, by using this arriving the conclusions, so you can see this hash London having very less when compared to whatever the values we had on the past, like northwest, and also the pink color shows as a southwest. So when compared to these two, it is very low. In the 22 well, it is very peaked, right? 22 well, it is very peaked when compared to all the other values. So the northwest having the very high value when compared to the all. And you can see this is very narrowed kind of the plot, or very narrowed kind of the line plot we're going to be seen for this pink, and also the shadow color, and along with blue color, and along with this light ash color. So the number of spikes are very high when compared to whatever we have observed in 22 well. So let's also focus more on what exactly the some of the regions having the spikes when compared to the accidents. Let's only focus more on these whatever the spikes we had. So in the different kind of the region having different kind of the spikes, as you can see the red color and also the yellow color and the blue color. So just now we just now drawn some of the conclusion with respect to whatever the England regions we have. So these are the four England regions are very high spike. Under that is the north wind is the very high spike when compared to all the observation. So you can draw this conclusion with corresponding to whatever the spike we had. This is regarding only for the region, so that we will able to also arrive at the solution with corresponding the 22 will what exactly that needs to be happened, that spike going to be increased like. And let's also check about road accidents in the UK based on the different regions. So between the 2015 and 2014, so the number of casualties we had, and along with the different regions, number of casualties are very high for the southeast, as we just now seen with corresponding to the 22 well data sets. But as per the casualties we had southeast, the first, and also the London, and along with the northwest. So the northeast is very less when compared to whatever the number of casualties we have. Yeah. So there was occurrence highest the road accidents are the southeast and also the London. So England has the least, very least, right? So northeast has the very least when compared to all the other regions. And along with, we can also figure out the way what exactly the highway authorities. So we have drawn for the region. So we know that west south is very high when compared to all the other in 22 well. So let's also go with the highway authorities, the most dangerous or maybe the safest in the UK based. So let's play around with the accidents record, whatever we have from 2005 to 2014. So just check about the top 20 results so that we can go with corresponding the highway authority using the UK data sets. So let's plotting with the highway authority data sets, the summation with corresponding to the number of casualties. So the number of casualties with corresponding to the highway authorities are Kent country and the survey country and Lushnite country and XN country. So with these corresponding highway authorities, and let's compare it to the these one, Liverpool City and Oxford Science country. And also we can also go with the safest one. So whoever having the very safest one, that means the lowest record which needs to be bring on top, right? Eastern where Middleton and East Lowton. So these are some of the state-based highway authorities. So Kentron is the most notorious highway for the road accidents, while East Ayrshire is said to be very safest among all the other authorities between the 25 and 2014. And also you can also talk about with corresponding to the which day and also the which month it is, and along with what is the particular day and also the time, which is also required to get to know about why that spike is increased in 2012 and what are the assumptions to get in terms of that. So let's play around with country by country and along with the year by year. So by using these kind of the data, we can arrive the solution with corresponding to whatever the info. This piece of the code is very straightforward once you get some hands on with the Python and also whatever we have discussed in the previous classes. This is directly straightforward stuff. So I'm just going to be skipping this part so that we will able to focus more on the plots to get some kind of analytic thinking. So this is a plot we are going to be get for the occurrences of the road accident by weekends in the UK between 2005 2014. So day of the week this is. So we're going to be get for the month and also the Tuesday, Wednesday, Thursday. So you can see most of the accidents or most of the casualties going to be happened on Saturday. Okay, on Saturday, and also the Friday. Let's say Friday and Saturday, but most the peak value is Saturday, not as a Friday when compared to all these values, and very less in the Monday, very less in the Monday when compared to all other weekdays. So let's also see the hour wise. So we have drawn some of the conclusions. Only the Saturday having the very high peaked value for all the cases, for and also the all the belongs to different kind of the countries and also the region. And along with you can see the hour wise it's slightly high for the 17, that is the 5 p.m. IST. If you are Indian, 5 p.m. IST when compared to whatever the IST stand for, and very less in 4 a.m., which is very morning days, so no traffic, nothing is there, right? So at the time we don't have that much occurrences of the casualties. The number of accidents are very less when compared to all these cases. So only the evening period we had too many accident cases from afternoon to the evening. So we can also see those are the conclusions we can arrive from the hours and also the day of the week. We can also see the week in a month. So a week in a month, which basically tells about which month is in the week. So that so you can also see the week in a month having the fourth month. So fourth week is very high when compared to whatever we had. So last weekend you can say, and also the months. So different months we had, so it is something with jumbling, not we can say particular peak, right? So there is no kind of stationality here. We can, you cannot draw some of the conclusion by using this, but I would say very less in February as a pattern I can see here. And also I would say the very high pattern maybe corresponding to the September to October, with the February is a very low with corresponding to that. So based on this weekend, we already seen Saturday is the most occur in the accidents, and while is the least occur in the accident to 2005 to 2014. And also the based on the hours of the day, in the morning hour is the very high occurrence, that means of the low accidents, and 12 to 4 a.m. the least accidents, with corresponding to 4 a.m. having the lowest occurrences. So based on these kind of the weekends, first 4 weeks in a month are relatively same regards and rate of accidents, and the fifth week is the most not frequent, so that's the reason we don't have least occurrences. Along with we also drawn conclusion with corresponding to the month. The February has the least recording accidents, while October having the most recording accidents. So it depends, and same average kind of the ratio. It's also present in the May and July. That's the reason. This is not a stationary. We cannot draw some of the conclusions corresponding to this. Let's also see which particular road or the network group having the base most dangerous or the maybe safest one. So we're going to be drawn some of the conclusion with recording the region and also the time and also the with corresponding to the number of occurrences, right? So we can also see with corresponding to the network groups or the particular road. So we can also have the data set with corresponding to the subgroup descriptions. So by using that, we can arrive some of the solution with corresponding to the different kind of authorities. So yeah, these are the very sample description with corresponding subgroups. We can draw on some of the conclusion with respect to this. And along with, we can also do some kind of the visualization with the subgroup description and the road networks with the UK lower or the highest records. So I'm just going to be plot with corresponding to the bar plots, which maybe tells about what are the different authorities we had with corresponding to the number of casualties. So the number of casualties are very more in the sparsely networked rural authorities and very less for very sparsity network, very rural Scottish Iceland. So we can dare some conclusion with corresponding to the road type so that we will eventually get what exactly the information with corresponding to the road type also. So single carriage highway. So this may be having very number of casualties and sometimes unknown. So unknown may be drawn from the different of the perspectives. So they may not be named or properly, but eventually we can the slip road having very less number of casualties. So we can also have the observation so that we will able to identify. So sparsely network rural authority road network has a high occurrences of the road in the wild UK, and very sparsity network rural Scottish Island road network has the least occurrences. Single carriage are the high occurrences when compared to the all. So we can also derive the solution for the what condition, taking all this into account. So whether the road or light conditions caused by the most number of the accidents. So we determine the surface conditions, right? So what exactly the surface condition, weather conditions we do have. So let's play around with a couple of the data sets so that we will arrive the solution with corresponding to those. So yeah, so what exactly the columns we're going to get? So the unique number of the records with corresponding to this is temperature, dry, and also snow, flood, like this. Weather conditions also remaining this. So let's play around with kind of the group by data set so that we'll eventually get some kind of idea and analysis over these kind of the results. So different conditions having the different summation and also the number of casualties. So let's say, so find without high winds and day light and also the street light as present. That means there are so many fine results having the number of casualties are very high. Only few of them. So let's say fog or maybe the snowing without high winds, a darkness, street lighting unknown maybe. So fine with the high winds. Okay, so this is fine without high winds. Okay, so fine with high winds which are having the very low casualties. It does not affect the road where vehicle may not be, but it simply has the most become the road accidents are going to be said like that. Fine weather conditions without a high winds, so that is going to be very dry road conditions at the time, so that it will eventually drop. On the other hand, we can also see the more number of accident does not occur. There is a flood or maybe the darkness of the slope. So the next question is in this EDA analysis. So drawing some of the questions and conclusion with corresponding to the plots. So we will eventually get good understanding of the exploited data analysis so that we will able to identify these kind of observations into our modeling perspective also. So is pedestrian crossing a cause of the road accident or maybe the influence of the road causalties in the UK? So we have periodization crossing different kind of the columns. Let's check out them what exactly the distinct kind of the conditions under the predictions. So these are the different distinct conditions with no physical or prediction phase, the traffic signal junction or non-junction. So let's play around with these kind of the plots so that we will able to identify with corresponding to what exactly the registrations with number of casualties. So none with the 50 meters, no physical crossing within 50 meters. So these are the very high when compared to all the other, and very less with compared to the control by school and also the crossing the petrol maybe. So commonly does not occur the registrations of crossing maybe do not may not be affected with corresponding the road accidents in the UK between 2005 to 2014. So the next question is how many number of casualties occur per accident in UK? What is the distribution in terms of total amount road accident that going to be occurred in this? So we need to know number of the casualties occurred per the accident in UK along with the distribution also. So let's plot about the distribution as we already know about how does the distribution going to be works out. The frequency of the distribution it is not normal distribution but is having some skewedness with the right. So so let's plot with corresponding the number of the vehicles. So this number of the vehicles we had. Distribution is completely rightly high skewed. We already know this is similar to the similar of the vehicles also rightly high skewed. At the speed limit, what exactly the speed limit with corresponding to get the road accidents? The speed limit is very average is 30, but mean value is 30. That is the way. But violating has a 60, 70 is also very high when compared to all the other values. That may be cause one of the number of casualties are very high. So which area having road accident the more frequent and also the what is the distribution for the severity. So let's plot about the region wise distribution so that we will able to understand with the focus of the pie plots. So yeah, you can see the distribution may be happened with corresponding to this is around 80 to 14%. So it does not include any kind of the 210 or 3 standard deviation with corresponding to the percentage of these road accidents. The occurrences of these two accidents are very high when compared to the road accidents also. So most of the road accidents are very slightly severity. Okay, so on the victim side also the minute of the road accidents is better. So we can also see in the next video for the model building for the time series analysis so that we will able to identify the future predictions of the UK road accidents. Thank you.